Okay, this is lesson 4, measuring water in the atmosphere. This is mostly a vocabulary lesson that will go over the terms you're going to need to know and use as we go through weather. First one is evaporation. Evaporation, hopefully you knew this from 4th grade, water moves from a liquid into a gas. So as water disappears from a wet piece of clothing, it is evaporating up into the air around you. So you're breathing in all of the things that have evaporated in the past. Okay. Now as evaporation happens more and more and more, what might happen is that air gets full of water. And as soon as that happens, that air is saturated. So it is holding as much water as it possibly can when it is saturated. Now here's some drawings. Okay. One thing, easy way to remember this, you ever been in a shower? There's a lot of evaporation happening while you are showering there. You've seen that steam come off, leaves your bathroom really sticky and moist and humid. Okay. Now if you shower long enough and if you don't have a fan running, what you might end up with is saturated air inside of that bathroom. Okay. Well, you've got a nice cool mirror. What sticks to your mirror when you have a saturated air in the bathroom? Well, liquid water, yeah. So then that's called condensation. Condensation is forming on your mirror in the bathroom there. So water is moving from a gas into a liquid, or in other words, it's coming out of the air. The other way I want you to remember this would be with the water cycle. So you have sunlight hitting the ocean, causing lots of evaporation. This should be review. Okay? That air, as it moves upward, can become saturated and condense into a cloud. So just another way to remember exactly what we've gone over so far. Okay, moving on. Up next is dew point. Okay, the dew point, the next term, this is the point the temperature needs to get down to for the air to be saturated. So if the dew point outside right now is 60 degrees, and tonight the temperature dips down to 60 degrees, that'll mean that the air is holding as much water as it possibly can. It's the point where dew starts forming on the grass. The temperature that the air would be saturated at, given the amount of water in it. So if there's more water in it, the dew point is going to be higher. It'll need a higher temperature of air to hold that much water. Now humidity is a little bit easier. Humidity is simply how much water is in the air. So if there's a low humidity outside, that means there's just a little bit of water in the air. If it's humid, everyone knows what humid means. It means it's very wet outside. Our last point is relative humidity. Relative humidity is simply the percentage of water that it's holding compared to the maximum amount. So if there is 70% humidity, it's holding 70% of the maximum amount of water that air can possibly hold. Relative humidity is an actual measure, whereas humidity is the term just for it's humid, it's not humid outside. Now to help illustrate this, let's say we have a winter and a summer day. That winter day, let's call it the 27th of January. The temperature outside is 33 degrees. The dew point is 23 degrees. So if it got down to 23 degrees, the air would be saturated. That means the relative humidity is about 70%. That 33 degrees of air is holding about 70% of the water it possibly can. Now, the water capacity of the air on this 33 degree day is kind of small. Okay? It's not a huge box. And that box is about 70% full. So if it were 100% full, that air would be saturated. If the dew point were at 33 degrees, that means it would be 100% relative humidity, and that capacity would be filled. On the other hand, in the summertime, let's call it the 20th of July, the temperature might be 89 degrees with a dew point of 75 and the relative humidity of 79%. So What's the water capacity of the air going to look like? Well, it's going to be much larger. So the capacity of that air to hold water is going to be much greater on this day in July than on the day in January. So if the day in January was 70% full, that's about this much water. If that day in July is 79% full, that can be a whole lot more water than that day in January. 79%. All right, so to review, a cold day can only hold so much water. It's a smaller capacity than a warm day. And that warm day in July is going to hold much, much, much more water than a day in January.